Hello, my name is Janene Koura-Bodji, and I'm a 16-year-old NASA's intern for the summer of 2022. This summer, I was fortunate enough to work with experienced mentors and teammates in the Air Quality Initiative group. During my time in this internship, I created a research project on air quality with environmental and health aspects, which is what I'll be presenting to you today. I'd just like to say thank you to all of you in the audience who are watching the symposium and for taking the time to watch my presentation. And with that, I'll now present my research project, which is air quality, varying ozone trend in relation to environmental health. So, to let you guys know a little bit more about me, I'm currently a rising junior at Cohen High School, and I live in Fredericksburg, Virginia. I live with my parents and have an older brother who's in college. I play travel soccer, and I also played for my high school team this past year. I plan to major in biomedical sciences and hopefully become a medical scientist, which is why my project involves health relations to air quality. In this presentation, I'll go over some background information, the site I use to properly present my data, and my final conclusion for my research project. So, between 2016 and 2018, there was a decrease in crop yield and ozone prone plants such as cotton and peanuts. At the same time, there's been a rise in nutrient deficiency diseases that have led to chronic illnesses. For my research project, I focused on how ozone can affect crop yield, and I then made a relation to nutrient deficiency diseases and secondary complications, such as heart disease, high blood pressure, etc. With my project, I was able to use a website called ArcGIS Story Maps to create a platform that has a record of all my research data analysis. So here's my research question and my hypothesis. My research question is, how does ozone influence agricultural contributors to public health? And my hypothesis is, if different regional areas in the US exert high ozone levels than other regions, then it will cause inadequate crop yield in the same regions that produce those crops, which will most likely lead to spike in nutrient deficiency diseases and secondary complications. So here's my introduction with all the information that I already discussed. And here is a slideshow for the US regional areas based on the EPA, which is the Environmental Protection Agency. So, for example, we have the Northeastern region, which has some states like Maryland and Massachusetts. And here are the agricultural areas. So, I looked into three main crops: soybeans, cotton, and peanuts. So here's the soybean crop area, which is mostly found throughout the middle parts of the United States, as well as some parts in the South and East Coast. We have cotton crop areas, which is spread out throughout the southern half of the US, and peanut crop areas, which is between the south central and southeastern parts of the US. So I first looked into ozone trends by US regions. According to my hypothesis, the South region should experience low crop yield compared to all the other regions because most of the crop planting and relatively high ozone levels correspond to this region. Based on the data, it's noticeable that the southern region's ozone levels have continuously increased over time compared to the others that only fluctuations in ozone levels. I then looked into crop yield. So typically soybeans, cotton, and peanuts are crops that are most negatively impacted by ozone increase. So soybeans have generally increased over time between 2016 to 2018 and become the most abundant crop produced in the US. Cotton has some fluctuations, mainly because of the decrease from 2017 to 2018. I believe this is due to the immense ozone trends in the states and crop areas that produce cotton, so it would cause these weird fluctuations. And peanuts have generally decreased over time, mainly because of the area planted. So in 2017, the area planted was higher than in 2018, therefore, the reduction was higher in 2017 than in 2018. So, normally with my research, I believe that cotton production would be higher than soybean because of its abundant use in the food industry. Cottonseed oil is used in many salad dressings and processed foods and even served as frying oils in some restaurants. Businesses tend to use cottonseed oil because it's usually cheap and can preserve foods for long periods of time. Peanut oil is also used in restaurants as well, but not as much as cottonseed oil. So, with further research, I was able to find that soybean oil was relatively cheap between 2016 and 2018 and even decreased by the end of 2018. However, with cotton, it was very expensive and even increased by the end of 2018. From this, I deducted that the reduction of more soybeans caused prices to be cheaper, allowing for more businesses to buy more soybeans or soybean oil to be used. This trend most likely indirectly caused less cotton to be produced, hence increasing the prices, and fewer companies use them despite its versatility. This concept of cotton would also, I would say, apply to peanuts. So, where the nutrient deficiency comes in is that cotton normally has a lot of potassium and peanuts have a lot of magnesium. However, cotton has a toxin called glycopol, which is naturally produced in the plant to protect itself from insects, but harmful for us and other animals to ingest. And when translating this cotton into cottonseed oil, factories and businesses refine it, hydrolyze it, and even bleach the oils in order to create cottonseed oil. Yet, even though it takes out the toxin in cottonseed oil and even the allergic properties of peanut oil, it also takes out their nutrients. And so now people are eating a lot of processed foods with not as much potassium and magnesium as needed. Over the past 50 years, there has been a relatively high increase in concern of potassium and magnesium deficiencies in the US. Therefore, I looked into diseases that are related to potassium and magnesium deficiencies. Potassium deficiencies tend to lead to high blood pressure and kidney disease, and magnesium deficiencies lead to high blood pressure, heart disease, and diabetes. As you can see here, between 2016 and 2018, there was a relatively high increase between most of these diseases, therefore, generally advocating my hypothesis. For my final conclusion, my hypothesis was generally correct, but more minor factors were needed to be implemented to correlate my original aspects. For instance, the prices of crops were not in my original research, where I simply focused on other trends, crop yield, and nutrient deficiencies. However, this factor was needed in order to properly correlate my topics, but did not reflect in my initial inferences. So, for my methodology part of my project, I first looked into a series of live websites that could track the quality of atmosphere and other environmental factors such as heat. When I saw a prevalence of extreme temperatures in the southern region, it gave me the idea of relating some sort of greenhouse gas to crop yield and disease, which is were topics that I was previously interested in. I looked through many medical articles and agricultural documents, and I could finally correlate all of my data and information together with my research question hypothesis. As a analysis intern, I generally had a great experience in Austin, Texas. I was able to create a successful research project that incorporated my interests from the medical field, and I got to meet new people that were different yet had similar interests to me. I was able to group an amazing group of people who were very lively and that were a blast to have around. I again would like to thank my mentors for their experience and guidance that they have given me in making this project. As well, I'd like to especially thank my teammates, for without their adjustments and suggestions for this project, it would not have been as solid as it could be. I again thank you all for watching and hope you enjoy the rest of this presentation from our air quality team, as well as other groups presenting in this symposium.